Hello everybody and welcome back to more of the Pascal paper from the year 2006. We're looking at question number 22. In the diagram, each of the three identical circles touch the other two, so they're tangent. Okay. The circumference of each circle is 36. That's kind of odd. I would have expected a pi somewhere in there. What is the perimeter of the shaded region? Ooh. Interesting. So, the shaded region is the area that's in between all three circles. Let's draw this picture. Get ourselves a new piece of paper. Question 21 clearly took a page. And we will draw... first of all, these guys should be tangents and no overlaps. Maybe that's a little big, though. Well, as long as I know that they're circles, I'm fine. Yeah, that bottom one, that you got really flat there. Anyway, so we've got our shaded region here. Diagrams don't have to be exact, especially if it's in your rough work. And we'll use the red. So we want the perimeter. And the perimeter of the shaded region goes from where each pair of circles touch along the circle. So we want this. So where the circles touch is pretty important. Now, anytime I see circles touching, and they are identical circles, so things we know they're going to have the same radius, same area, same perimeter. Anytime I see anything just come in and touch the circle, I always connect it up. Always. That is always my instinct, every problem. Doesn't take too long to connect them up. Sometimes it can really help us out. So that's a pretty big center there. Okay. So, what's going on here? So, if I were to, this is just for the people who like being super exact, if I were to draw a tangent line, a line touching both these circles right through here, both of these radii would meet this blue line at right angles. Okay? It really doesn't look like it on my picture, but it really does. And that means that these lines here are actually all together, and they connect the centers of the triangles. The centers form points of a triangle. Now these circles are all identical, so the radii are going to be the same. I'm going to call it R because I really don't have anything else. Maybe we need to solve for R. I don't know. But they're all points of our triangle. But we can see our triangle has side length 2R. So not only is it are the points of a triangle, points of an equilateral triangle. Okay, and equilateral triangles have 60 degrees for each of their angles. Okay, well, hey, the red lines that I want for my perimeter, it's 3 copies of this arc. So it's 3 times the arc length of 60 degrees. In this particular triangle. I know I could get a formula for it in terms of R, but I actually don't think I need it. Okay? If we imagine a full circle here, how many degrees in a full circle? 360 degrees. So if we just wanted, if we wanted to talk about the full perimeter or the circumference, we'd have the full 360 degrees. If we just want a portion of that circumference, a pie slice of 60 degrees, it's going to be, so 60 degrees over 360 degrees is the same, has the exact same ratio as the arc length of 60 degrees over the arc length of 360 degrees. So this guy over here, he's 1 over 6. Arc length of 360 degrees, that's the full circle, that's the circumference. So 1 over 6 equals the length that we want. The red length, a single one of these red lengths, and it'll be with the circumference. But I was told the circumference is 36. So rearranging, our arc length is 6. 36 over 6 is 6. So the perimeter of the shaded region is 3 times 6, or 18. And 18 is the first one, A. Okay. So you could have done this question other ways. You could have solved for R and been a bit more exact. For example, in terms of R, we'll just write it down very quickly here. If I've got a circle of radius R and I want the arc length of theta degrees, then there's a formula for that. It's theta over 360 degrees times the circumference. That's why these ratios work. So 2 pi r. Okay, and you could have used that. You could have solved for r. I tried to avoid it because r isn't going to be nice. It's going to be 360 over, or sorry, 36 over 2 pi, which is going to be 18 over pi. I don't want to use that formula. I don't want to use that r, and I don't need to. I can just avoid it and use angles and the given circumference to answer the question. Okay, but there's never just one. Well, there's hopefully never just one way to do a question. This one has a couple approaches. Do I solve for the r or not? Okay, but that does it for question 22. Hopefully you've been liking the Pascal. Feel free to like the video, any of the Pascal videos really, or subscribe to be kept up to date. But either way, I wish you guys well, and I will see you for question 23 in the next video. So long.